it's 3:30.
Oh, my computer. It's time to start. Yes, welcome to linkengineering.org's video conversation series. My name is Shelley Latham. I'm the community manager for Link Engineering, which is an engineering educator exchange sponsored by the National Academy of Engineering and with sponsorship from Chevron. And we're very excited today to have Beth Van Meeteren with us. She's the director of Iowa Region Center for Early Development Education. And she's going to talk to us today about building literacy with PK through second grade engineering experiences. Beth is going to start us out by telling us a little bit about how she got into this combination of literacy and engineering and what her background is in this. So Beth, welcome.
Thank you. Thank you for having me. I am the director of a center that represents all 3 state universities in Iowa. So the 3 little pinwheels stand for all the different colors of each athletic team that they have. University of Northern Iowa is where I am housed, but then the University of Iowa is just an hour down the road. And then Iowa State, close by Ames. I represent all 3, but again, at University of Northern Iowa. I put a picture of me as I was just getting ready for my first day of school here, because I want to share a few things about why that's important in the part of this discussion. I grew up on a farm in Iowa, and I had a very rich experience learning about the world and how it worked on this farm. I grew flowers and vegetables with my mom and learned botany and entomology, and I did so on a larger scale in helping my father in the field. I gained an understanding of life science and anatomy as we raised cattle and hogs and chickens, and we milked 26 cows. And then I also got to engage in reverse engineering when I was stranded out in the field with broken equipment in the days before cell phones. And I had to either fix it or wait hours until someone figured out that I wasn't coming home. So I've been in formal school since I was 5 years old in one capacity or another. But I think my expertise in engineering was not served well in my formal schooling. And that's something that I hope we are rectifying in our schools today. A little bit of where I've been in school since I never left since I was 5. I have a bachelor's degree in social science, and that gave me a window into what the thought processes were in teaching and learning. I hold a master's degree in literacy, which gave me some insights on how children make sense of the written word. I taught first grade for over 20 years in a rural school and also in an urban school. And I earned a doctorate in curriculum and instruction with an emphasis on early STEM or early engineering. And I found myself reconnecting with my experiences as a child as I started to do research on what engineering is in early childhood. So the goal for this webinar, I'd like to examine the components of literacy development alongside the components of engineering development, and then hopefully we can consider the synergy of integration between the two. So when I attend workshops on engineering for younger students, almost every single workshop connects engineering with reading. And this kind of makes sense as reading dominates instructional time in early elementary right now. The engineering lessons typically start by reading a book about engineering to get young learners interested in engineering. And some of these books are fictional, a few are informational, but most engineering approaches connect reading to engineering by including a picture book. And that's okay. That is a way to connect to engineering, but it's only one component of literacy. And we're going to focus on the other components of literacy, starting with the foundational skills that are part of the component of reading. Those include phonological awareness, print concepts, phonics, word recognition, and fluency. And if you are a kindergarten, first grade, second grade, third grade teacher, you know these things very well because our nation has been heavily focused in our public schools on these foundational skills in literacy, to a fault, I might add. That's another conversation here. But so to those of you who might be in informal learning that don't know about literacy instruction, phonological awareness deals with the ability to recognize sounds in our spoken language, and then the print concepts deal with how print works. And what that means is that if you were looking at a page of print on the right side, in our language, we're going to start to read it in the upper left, we're going to read to the right, and then we're going to return to the next line, read again to the right, and they call those return sweeps. And if you are a reader of English, this is how our world of print works. But not all languages are designed in this way. Other foundational skills include phonics, or the pattern in which we arrange letters to represent chunks of sounds to create words, word recognition, or the ability to read a word without a great focus on the letters and sounds, and fluency, or the ability to read and comprehend print well enough in order to read it with expression and make it sound very much like speech. All of this is done to develop as readers, but literacy development must also include listening, speaking, and writing. And these are very important components that go side by side with engineering development. Engineering is a wonderful context for learning all of the components or tools of literacy, because literacy is a tool. It's actually technology when you think about it. It's a system that humans have created to serve the need to communicate, to learn about the world and how the social relationships work. It's how we stayed safe from the very beginning, and it's how we developed as cultures as we used literacy to communicate as we went on. We engineer our language to communicate, to write poems, write songs and novels, and we engineer our language to document and communicate what we are creating or learning. So it's very easy to see that literacy and science processes are very similar. Engineering experiences can be extremely helpful in developing skills in literacy. So for example, at the top, in literacy, one of the skills is to note the details in print. In science and engineering process skills, we want to observe and retain some small details of what we're observing. In literacy, we compare and contrast characters, types of genres, what's going on between one version of a story with another. And in science and engineering, we compare and contrast things in the world and to make sense of how they are working. In literacy, there's a sequence of events that follows a set of rules in order to make a poem or a story or a script for a play. And in science and engineering, we have a project of logic and analysis in order to tell our story about what we're figuring out. There's cause and effect in both. In literacy, it's important for us to distinguish fact from opinion. And in science and engineering, the focus is on the use of evidence to support claims, which ends up being facts. In literacy, we make inferences based on comprehension of what's going on in the story. And in science and engineering, we make inferences based on what we're observing and evidence that we're seeing in what we're trying out. Both domains, we draw conclusions. And in literacy, we link words with precise meanings through experiences, but then this is done with a greater detail, with a more narrow focus in science and engineering vocabulary. So you're going to see words in science and engineering that might be quite different than words that you will see in children's storybooks that are not linked to engineering or science. And most kids really cut their teeth on narrative books. And so they aren't really used to a lot of those kinds of science and engineering vocabulary. But we have found that engineering is very powerful as a tool for learning literacy because it illuminates how the world works. And by engaging in experiences, we start to develop those conceptual understandings as we're examining this. And through this, we grow in our capacity to reason. We grow in what we use to know about how the world works, and it challenges us to re-examine what we thought we knew and take a closer look at things and then gain a deeper, a more accurate understanding of concepts. Engineering experiences are all about forming the mind or to exercise your brain or thinking, which results in increasing your intelligence. But it goes so much farther than memorizing facts. And Florence Kohlberg and Rita DeVries wrote about this as education is about forming the mind, not just furnishing it. So it's furnishing it. So it's going beyond just memorizing facts or memorizing things to spit back, but it really changes the way your whole brain processes things. It's forming that mind to engage in logic and reasoning. Engineering is often thought of as part of the acronym of STEM. I almost never see it outside of the context of STEM. And actually, if you have engineering, you have all the letters in STEM, whereas you can do science without engaging in engineering. You can do math without engaging in science or engineering or technology. But if you're doing engineering, you're engaging with science, technology, and mathematics. And I think that's why it's such a rich tool to use in the school setting. Science, in education, we focus primarily on 3 domains in science. That's life science, earth and space science, and physical science. But this has really changed in education since I started going to school. Whereas before, science was talked about as something that you had to memorize. And then there was this scientific method that was taught to us, that we had to learn the steps of the scientific method. And then we were given experiences or experiments that would follow the steps of the scientific method. And if we got the answer that was in the answer key that the teacher had, we knew we had performed the experiment correctly. Well, that really isn't an experiment. It's following directions is what it is. And what the National Research Council is trying to do, and science education has been trying to do, is rid itself of the whole idea of the scientific method. They said that's really not how scientists work. That the science is much more messy. It's they might write up their research reports like a scientific method, but to do science in education is more powerful. And so the old way of science education was more about furnishing the mind of facts to memorize, and science education is now focusing on helping kids to do science. And in the process of doing science or engaging in science inquiry, they're developing scientific habits of mind. And the way you can think about how well you're doing with this, if you can look at your children in your classroom, and if you can imagine that they're saying, oh, I want to observe that more closely. Oh, that makes me wonder about, so that they're having their own questions, and that they are driven to gather information to find answers to their questions. And then maybe they find out that they were focused on a very low-level question, that maybe they should have been asking a question in this way. So you let them change their mind, their direction of their learning, so that they can keep gathering information. And then in their exploration, they might even change their mind on what they're investigating. But that's the whole messy process of sciencing. And that's what science education is trying to help elementary educators to understand, that it is more helpful, it's healthier to approach science as inquiry than as something very rigid as following steps to the scientific method. So the next letter in the acronym is technology. And when people think of technology within STEM, their mind immediately wants to go to computers or cell phones or iPads. And my mind does that too. But I think that's a very narrow focus for what the word technology is. And the definition from the National Academy of Engineering is the process by which humans modify nature to meet their needs and wants. And the International Technology Education Association defines it as the innovation, change, or modification of the natural environment in order to satisfy perceived human wants and needs. And so you can think about technology aside from computer technology, and you can think of some very simple technology. For example, when somebody's feet started to get cold, they designed a shoe to serve the need of keeping their foot warm or protected if they were walking across rocks. If they were trying to keep their shoe on their foot, then they invented the technology of a shoelace that would tie the shoe onto the foot. And if you were frustrated by rethreading that shoelace and it was all frayed, there was somebody that invented the technology of an aglet, which is that little piece of plastic that goes at the end of a shoelace that helps you thread that shoe a little bit more easily. So technology does not have to necessarily mean computers or something that is driven by batteries or electricity. If we think more broadly about technology, our world becomes much more interesting to us. And so now let's just substitute the word human with children, the process by which children modify nature to meet their needs and wants. Then that helps us look at things a little bit more developmentally appropriate with young children. And when I started doing this, I started to realize I was misidentifying some behaviors as misbehavior when actually they were trying to make something that I was having them do that was very dull, trying to make it more interesting. And the example I like to give my students is, as a first grade teacher, you have that old saying, March comes in like a lion and goes out like a lamb. And so there's this old, tired routine that first grade teachers will do is they haul out the cotton balls and they haul out the paper lamb out of construction paper. And then they integrate math by having them count the cotton balls, and they practice one-to-one correspondence by doing a dot of glue and a cotton ball and a dot of glue and a cotton ball. And I can remember one time this little boy was doing this, and he kind of had his hand and holding his head up. And then I noticed he took the lid off of his glue and he had poured it all over his construction paper, and he was lifting up the paper and kind of tearing it. And I gave him another piece of construction paper lamb and corrected his behavior. But in retrospect, he was really trying to make something a little bit more interesting. I wonder now if he was noticing how the glue saturates the paper and how it makes it tear more easily. And, oh, when I tear the paper apart, look at these little pieces that are they almost look like thread. So I think now I look back to things that I did with my children in first grade that may have been terribly boring things for them to do, and things that were furnishing their minds when I could have created experience that would help them form the mind instead. And that child was trying to teach me something, and I was not listening. I was not very much in tune with this. So here, let's think about what engineering is. Engineering is new to early education, and it's been a struggle to make it a good fit. And teachers know children, and lucky young children have teachers who also know child development. But these teachers rarely feel comfortable in teaching engineering. And so those that are ready to take it on, they seek lots of materials to help them teach engineering. They go to Pinterest or they go to curriculum programs that have it all laid out because they don't feel confident in being able to work with engineering with young kids. And it can be difficult to go through that engineering material because kids often have other ideas rolling around in their heads. And in Iowa, we have snow, so I'm going to use the illustration of a child playing with snow. And one of the things that brings them absolute joy is when the snow is just the right consistency and we've had a really healthy snowstorm. They like to make snow forts, and they go to where the banks are, and they like to chop these chunks of snow out and they carry them to another place and they start to build snow forts. And so here you have this example of this teacher that's excited about teaching engineering to the class, and she's working really hard to teach them about engineering and to practice what engineers do. And the child's coming into the classroom from recess. Oh, when's the next recess so I can get back to building snow forts? So in the early engineering curriculum materials, they often walk teachers through a process of breaking down an adult idea of engineering into simple parts for young children to try to lift them up to the adult understanding of engineering. And it often begins with the idea of telling children that engineers solve problems. And then because the STEM industry is really wanting to have more and more STEM employees, STEM-literate employees, they really want to plant the idea of becoming an engineer in young children's heads. And one of their biggest beefs is they'll ask children, what is an engineer? And if the child says, well, an engineer drives trains, it drives that person absolutely nuts. But they're not incorrect, because there are engineers who do drive trains. And so it's getting upset about that, I think, is kind of a lost effort here. Because there are a lot of people that hold doctorates, but that doesn't mean they wear white lab coats, and that doesn't mean that they're going to give you a vaccination or keep you healthy. There's lots of different doctorates too, but nobody gets bent out of shape over that. And so you have to take a broad look about what engineering is, and yes, it includes people that drive trains. And yes, you can be an engineer when you grow up. Oops, I did it again. And then they try to teach them what engineers do by walking them through an engineering design process. And there's usually a culminating activity that's done by following the steps of the engineering design process. And so now the teacher's saying, we just read a book about what engineers do, and now here is a problem for you to solve, because engineers solve people's problems. And so your job is to work in a group to design a solution, because engineers work in groups. And so you have to learn to work in a group. And so engineers, they draw up a plan because they want to save money before they create the product. So you draw your plan up before you create your solution, and then you test and improve your solution with your group. And by doing that, the idea is that you have brought this child up to this adult level, this adult understanding of what engineering is. And meanwhile, the kid is still thinking, I have to find a snowbank that is really packed really hard to get those blocks of snow. And what the teacher is actually doing is, now she's thinking, now you know what engineers are and what they do, and maybe you'll be an engineer someday. And the child's thinking about when she holds her hand like a karate chop, she could slice through those snow bricks. And if you look at what she's doing, she's really engaging in engineering behaviors already. And so the teacher's ready to go on to the next unit. The child is still engaging in the engineering activity of trying, how am I going to keep that wall from falling down all the time? What are we doing wrong? How are we stacking those snow chunks that keep the wall from falling down? And so I'd like to introduce the idea of not just early engineering, but developmental early engineering. And this is another perspective that needs an attentive teacher that listens to the children and knows them well. And so a teacher that listens to what kids are doing outside or what's happening at home or things that they're trying out, you can get an idea of when they are engaging in engineering behaviors. And building snow forts is engineering behavior. They're cutting out the blocks, and Dawn is carrying them over to the fort, and Whitney's stacking them, but one wall keeps falling over, and we're trying to make it stronger. So she's already working in a team, which is really kind of rare in early childhood, because most kids are pretty egocentric, and they resist working in a team. They're just sorting these personality things out. And so demanding that they work as a team to solve another person's problem really is a big leap for them. They're more interested in solving their own problems, and sometimes they need that privacy of trying things out on their own first. And then if other kids are interested, they might do some parallel work, and then they start sharing back and forth. So they kind of grow into that collaboration piece of it. And so instead of building the child up to the adult idea of engineering, the adult is looking at where engineering is already occurring in the child's life, and then how can you nurture and support those engineering ideas. So for example, the teacher is seeing that there is interest in building snow forts, and they are already designing and building, and they are already working as a team, and they even have a system in their building process. One child is cutting the bricks out, another one is carrying them over to where the fort is, and the other person is stacking them up. But they do have a problem, and that's a problem with the wall coming down. And they are highly invested in solving this problem because it's theirs. It's something that they really care about. And so if teachers think about what are the possibilities for learning in this interest, and how can I support their engineering behaviors? And I wonder how many other students are interested in this, and what kind of provocation could I make to get more interested in it? And is it possible to make a space and time for building structures, not of snow, but of other things in the classroom? So the first step, I think, in developmental early engineering is to sit back and recognize where kids are already trying to, not trying, they are engaging in engineering behaviors, and how can you support them? And a lot of times teachers will sit down and they'll make a web, or they'll make a list, or they'll do a storyline of how things could play out. And they think about all the possibilities. With snow, you can think about solids and liquids and freezing and thawing. With other kinds of building materials, you can think about the properties. Some are plastic, some are wood, some are hollow, some are solid. And then thinking about how this could start. Could you web around the world building? Or could you do a language experience activity about building a snow fort? What kinds of blocks could I bring into the classroom? So all of these things are swimming around until you come up with a plan to just get started. And then you and the child can co-construct how this engineering experience is going to be. And what we found is that instead of starting with a book, start with a child's story. And use that as an opportunity to engage in the shared writing or interactive writing, where the teacher and the child are both sharing the pen, or the child or the class is dictating the story and the teacher is writing it out on chart paper, and then they're reading it back. So here's this wonderful opportunity to marry engineering and literacy learning at the same time. And you don't have to bribe kids to stay invested in writing this down, because it's theirs. They own it. And so that interest is there. So I haven't talked about the engineering design process, you may have noticed. And when I first started doing some research on engineering, I read Engineering in K-12 Education. And they do mention that engineering education should involve design thinking, but they didn't specifically name the engineering design process. But they did talk a great deal about the most important part of engineering education is developing these engineering habits of mind. Very much like how we talked about the scientific habits of mind. And so one component of engineering habits of mind is systems thinking, creativity, optimism, collaboration, communication, and then there's attention to ethical considerations. And in the book, they have adult definitions of examples of how this works out in the engineering careers. But here I've tried to embed how children might be engaging in engineering habits of mind. So a child's engaging in systems thinking when you can see them thinking, oh, I notice when I change this part, I need to change the next part because this will impact that. So being able to hold multiple things inside their head, that demands a whole lot of cognitive flexibility and working memory to keep that all going. And it's a very powerful exercise in developing relationships, conceptual understandings, and intelligence. So systems thinking is very important. Creativity, if I rotate this piece, I can get it to fit there, or just it's embedded in the design itself to have an idea of how you're going to build or create something. Optimism, that's something that we hear a lot about. Kids are lacking this, and some people call this grit, and I kind of resist that. It's a little bit acerbic to me, but optimism, just, oh, if it didn't work this time, I'm going to try it another way and see if it's going to work this other way. That's a healthy way of dealing with it, where grit kind of implies, oh, I'm just going to stick this out and make my way through it because it's really painful, but I'm going to do it. But you don't really grow optimism in that way.
It's 4 o'clock.
Sorry, I'm halfway through. That's a good reminder for me. My time is going fast. Then collaboration, where this can work better if we all work together. And then communication, they want to tell everybody. And then attentions to ethical considerations. If I take all of these pieces, no one else is going to get any, so I shouldn't take so many. So this also works with literacy. I noticed that I change this part of the story, I'm going to change the other part. Or if I move this part of the story here, then I can get the audience excited to do this. Or when they're problem solving, when they're reading, oh, I didn't figure out the word that way, but if I try figuring out a word from another way, that's optimism as well. And then collaboration of reading together or taking turns reading or communication. Let's tell everybody, let's write about this or create this story or this documentation panel so that everybody understands what we're doing. And the attention to ethical considerations, the literacies, our words matter. How we speak to each other, how we talk to each other, how we relate to each other, it does matter. So engineering habits of mind isn't just for engineering, it's kind of 21st century thinking skills, which is pretty awesome. But everything that I learned about engineering in early childhood, I learned from kids. They really taught us what engineering is.